welcome to CS 112, lesson 13.4, functions or parameters. This is made for the University of Idaho CS 112 dual credit program. Today we're going to be talking about functions and parameters. These are both things that we've talked about before in the past. Whenever we're talking in either Scratch or NetLogo, we've used functions and parameters before. Today we do have a warm-up. The warm-up is the following. Take some time if you need to write the program down. For at least my classes, you need to provide a response of what is the name of the new function, why was 1 added to the random number, is size a local variable or is it a global variable, and post a 3 to 4 sentence explanation to these questions. That's in total, so maybe about a sentence each. Things to note on here is this slash star star slash. What that does is that makes it so that that entire section is seen as a comment. If you need time, please pause the video and resume once you have caught up. We'll be moving on. Okay. So, like I said, we've used both of these in Scratch and NetLogo before. We use procedures and functions to simplify code. Whenever you built the house in Scratch, you created code blocks to make squares and triangles because those weren't inherently made. We also made a pen position procedure to be able to tell kind of where you wanted it to go next. In processing, we're going to write some functions to help us simplify the setup and draw functions. You'll remember whenever we were doing Scratch and other things, we were always going for having as few things in that when that green flag is clicked, in order to kind of make it simpler and easier to follow and easier to understand, especially whenever you're doing things that are repetitive, things that we're doing over and over and over again. We want it to be able to, we want to be able to see kind of not as much. We want to just look at it and be like, hey, that's how much this is. So, like I said, we're going to make it so that this is a little easier. What we've seen so far kind of in terms of procedures and functions in processing is we've seen void setup and void draw. And the setup part and the draw part are typically pretty easy for students to understand. But where a lot of people kind of get confused is why that has that void. And what void says is it perform this task but don't return a value. Or perform this task and we don't expect you to return any value. We don't expect you to tell us kind of like a, hey, we're done with this task. So this is kind of this format that we use for draw is actually very similar to what we're going to use for processing. And you guys actually, if you copy down that warm-up, you actually have already made a new procedure, and you can kind of start seeing how this might work. So again, this is the same warm-up code. And hopefully you were able to go through this and you were able to make something happen. And what's going to be happening actually is, if you look along in the kind of the black section, you just be able to see it start rolling a 4, rolling a 1, complete. And if we look at our setup, we actually see how that works. The first thing that we say is start rolling, and that's the first thing that we see printed. Then it says roll 6, and roll 6 in and of itself isn't already made, and so we have to actually go down and define it, and we have to say this is what roll and this number that we're putting in there means. So we have roll, and then inside of that is an integer sides, and we have stuff happening in here. And so a couple questions that people have, or that we had on the warm-up, was what's the name of the new function? Well, the name of the new function is roll. The next question was, why was 1 added to the random number? You'll remember that random returns values of 0 all the way up to, but not including, the number that we say. So it still gives us the same amount of options, but it doesn't list it 1, 2, 3, 4, 5, 6. It actually goes 0, 1, 2, 3, 4, 5. And that point it stops. So if we look at this, we see, okay, roll 6, we have 6 options, but it'd start at 0, which if you've ever used a die before, you'll know, hey, it actually has 1, 2, 3, 4, 5, 6, and so we add that plus 1 on there. In this instance, in talking about variables, sides is a local variable. It only exists inside of roll. So if I go up into setup and I say something about sides, it's not going to know what I'm talking about. It's going to be like, what sides? Because sides only exist in this roll function. This 6 is a parameter. So it's what was sent into the functions. So we wanted to run roll, and we wanted to say, we want you to have 6. So if you're a Dungeons and Dragons fans, you can make it so that it was a D20, a 20 set of dice, and it'd be able to do it and say, we rolled a 3. Wow, that's pretty statistically weird that we got the same number. But rolling a 3, and we rolled a 3, and we could do it for practically anything. So 100. We did 100, 100. It passes 100, and it says, okay, we're going to go from 0 to 99, and then add 1 onto whatever you get. And we get the answers. Okay. All right, let's look back at the main screen. So the function definition is this: roll receives an integer value size and calculated a random integer valued n. And this number, this n, is actually reused farther down here on print for the println rolling a whatever we rolled. Okay. So parameters are values that are passed into the function. You should know this by now. If not, it's a good reminder of parameters, things that we push into our new function. The variable values being passed into a function have to match the data type in the function definition. And what that really means is I can't have a float and an integer, because those are two different type of things. If I have something with a decimal and something without a decimal, it doesn't really work. There is a way to make it so that it does work, but it kind of freaks out a little bit. So in the roll function, it defines size as an integer. Therefore, an error would occur if we put a float value was sent to the function. So let's go ahead and try changing this. Let's try changing a 6 to a 6.0 and see what happens. So if we look on our program, on our roll, we never defined anywhere that our, we didn't up here, we weren't integer roll or anything like that. We just have the 100. And so if I do 6.0, you can see right here the function in the red, hopefully you can read it. It says the function roll in parentheses expects parameters like roll and then parenthesis int, and then close that parenthesis. So what that says is, hey, you can't use a float value in here. You can't use a decimal. If I just change it to 60, it's totally fine with it. But by adding that decimal in here, it doesn't like what's happening. So like I said, we just got that error, and what that's telling you is that we can only get integers. We can't take any decimals or anything like that. Now, the interesting side of that, though, is, and let's see if I can show you this. If I do float, and I change this to 6, this should still work. Yeah, it still works. So floats are sometimes a little easier to work with because they are kind of adaptable like that. However, it gives you the chance of accidentally getting a half, and it's something that you should probably be addressing if you're supposed to get only whole numbers and somehow you got a decimal. And so it's kind of a good way of being able for it to be able to say, hey, just so you know, this probably isn't going to work the way that you want it to work out. So all functions expect a return type, the function name, any parameters, a code for the function. And the different thing that you can have is that you can have it return a value. And at the end of that function, it expects you to say return something, and it's something that it expects to return. It can be a float, it can be an integer, it can be a boolean, it can be a color, it can be a something, but it expects you at some point in time to return it and say, hey, this is what this program got out. A lot of times it's a variable, sometimes it's a 1, just to say, okay, we can continue on with what we're doing. So let's try the following program. I will pull it up on a processing. So I'm going to delete all this. So I'm going to go void setup. I'm going to make a float called qubit. And we're going to call it cube4. And I'm going to print ln the number cubed is, do a plus qubit. And I'm going to close my setup. I'm going to go float. So what this tells me is we expect it to return a float. Float cube. And we're going to have a float num. And we're going to have it make another float called new num. And that equals, oops, give a space there, num times num times num. And you'll remember cubing something is when you multiply it by itself 3 times. So number times itself, or a number times a number times a number, and that number's all the same. Then we say return new num. So what this says is we're going to make a number that's a decimal, and we're going to run this procedure to figure out what that is. And so expect that whenever we run cube, it's going to come back with something. And we do that actually right here where we say qubit equals cube to the 4th. And so it's not, if I just ran this without here, and let's say just say this was void, it would return as nothing because nothing really happened. And so when we say return new num, we're using this specific variable and saying, hey, return this. So if I run this, the number cubed is 64. So in being able to kind of show this new num is going to be a float, it's pretty strong in the idea that everything in this entire program is going to be floats. So float, 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 float. And what that makes it is it makes it very unlikely that we're going to have an issue because of a type mismatch, as we talked about. So let's go ahead and kind of review a little bit what we just said. So the value of 4 in this specific program was sent to the function cube, and that the function made a variable called new num, and it figured out that the number is actually 64 and returned that value to the statement that called it. So that's that setup statement. So that setup statement is the statement that called cube, and it did that. And so the statement printed on the console, the number cubed is 64. So again, the function is defined as a float, tells us that it's going to return a float, and so we need to make sure that those types are not mismatched, otherwise we can have an issue there. You can also change the value in that case. So instead of it being 4, we could have said 4.0, and this makes it a lot more easy for someone to use it as a program potentially. You can kind of think of it as like on your calculator whenever you use that squared button. It would be really unfortunate if the only thing you could do was 2 squared or 4 squared or 6 squared, but now you can do 2.25 squared, and you can do those odd numbers almost. So your assignment is going to be to take that polygon from lesson 13.2 and use a function and use it to make a function with parameters. And the way that we want you to set it up is we want to set it up as a void. Why? Because it's not going to return anything to its calling function. It's not going to return anything to hopefully your draw function is where you put that at. but have the specific parameters. So have your float x, have your float y, have an integer which is the number of sides, and a float which is the radius. That float x and float y, that should be the location that you're able to put the um, polygon. So then use the function polygon in the draw function. So you should be using specifically this whole polygon and then providing the parameters of where you want it, the x, where you want the y, the number size, and the float radius. Um, and so since it doesn't need to return anything, that's why you use that void. And here's the part that some people get a little bit lost on, is make 5 polygons, make 5 of them. So you're probably going to call it 5 times at different sizes and different number of sides at different locations. So kind of have fun with it. See if you can make it so that they're different looks. Make them kind of seem different. You might be able to figure out fill colors, maybe, maybe not, but definitely try at least changing the stroke. Um, After that, submit the program as a zip folder to as assignment 13.4 or whatever your instructor has this labeled as. For those of you in my class, this is going to be assignment 13.4. And then if you forgot how to do that zipped folder system, make sure you go and check out that zip file, zip a folder, so that you make sure that you don't accidentally zip just the program that you make. If you just zip just the program, it doesn't work. So make sure you check out that zip folder system, so then you make sure that you turn in the entire thing. So rest of the time, take some time, make those 5 polygons using that procedure that we just made, that function that we just made, and as always, happy coding.